I'll go ahead and kick it off. My name is Caroline Guo, and I'll be helping facilitate today's webinar. Thank you all for standing by, and welcome. Today we'll be talking about VCS and Terraform Cloud, where John will be walking through the integration and workflows of infrastructure as code with Terraform Cloud and your VCS. The demo today will primarily cover GitHub, and then we'll discuss further on GitLab, Azure DevOps, and Bitbucket. Please feel free to type in your questions during the webinar. This webinar is going to be recorded, and the recording will be made available after post-processing, usually within a couple business days. At the end, we will get to your questions in a live Q&A, so please remember to type them into the question box. And without further ado, our speaker today is John Schulman, Senior Product Manager for HashiCorp Terraform. John will kick us off and get us started. And with that, I'd love to pass it over to John.
Hi, thank you, Carolyn. Hello, everybody. Good morning. Thanks for joining the webinar. As Carolyn mentioned, my name is John Schulman. I'm a Senior Product Manager here at HashiCorp. I work on the Terraform Cloud product line. I am joined today by the fella in the picture there. That's my executive bird. If he chimes in at some point during the call, please don't be alarmed. There's no fire alarms going off or anything. That's just him. So to get started, the things that we're going to cover today are primarily an overview of Terraform Cloud, just real quick slideware, just to discuss what it is and how it relates to the Terraform you all know and love today. And then a little bit about what our VCS workflow looks like specifically as far as integrating with Terraform Cloud. Then we'll go into the demo. That's the most interesting part, of course. We'll live demonstrate some of these flows and how you can use them in your existing flows today. And then, as Carolyn mentioned, we'll go into the Q&A at the end. So please do put your questions in the chat, and we'll get to as many of them as we can. So to start, what is Terraform Cloud? So you're all familiar today with Terraform open source. At least I assume that many of you are. The goal of Terraform open source is, of course, to help you provision and manage infrastructure as code. So we have our HashiCorp configuration language, the HCL, that allows you to write that infrastructure as code and gives you reusable declarative objects that you can then provision and manage and lifecycle directly from the open source client. This open source infrastructure as code interfaces not only with you as the practitioner, but also via our public module registry, the community. And it has two main phases, the plan and the apply phase. Plan, of course, being a non-destructive, non-executive kind of way to give you output and tell you exactly what it is that you're going to be doing with your configuration file. And then the apply phase acts on that plan, and it actually runs it and makes it a reality for you. Whoops. The plan and apply phases, of course, they both interact with all of our major cloud provider types, whether it's AWS or GCP, Azure, VMware, Oracle Cloud, Kubernetes is on there. But really anything can be managed as code, again, due to the open nature of the community aspect of this, where anybody can create a provider and either have it certified and vetted through us and made available for others to use, or there are tons of ones that are published by HashiCorp itself. So really any infrastructure object or any object that can be interacted with via an API can be managed through Terraform. Now, Terraform Cloud builds on that open source model by adding things like a private module registry that can be isolated just to you or your company or your team working together, a UI and an API, whereas the Terraform open source model is very CLI driven. It sort of requires you to be interactive at the keyboard or executing as part of an external tool. The Terraform Cloud model provides a fully interactive, really well-formed API, as well as a UI for you to interact directly. And we'll be sticking more within the UI today. Terraform Cloud also provides remote state management. So one of the most important things about the Terraform open source model is the management of state within what is ultimately a flat file, the TF state file. Terraform Cloud allows you to manage that via our remote backend, which is a purpose-built system for managing remote state. And you can also invoke remote operations, again, using those APIs and UI functionalities against all of the same providers and resource types that you know and love and use in Terraform open source today. We also, add a lot of collaboration capabilities as part of that native UI. Having a team-focused collaboration model within Terraform Cloud is very important to us. So folks can work together. You can have teams. You can have permissions that are set on different pieces of infrastructure to ensure that only authorized users have access to manage and manipulate and deploy. You can work together with comments. There are multiple phases. Those plans and applies can have interactive models between them so that there's a little bit of a governance layer in there. And we do have the ability to provision, kind of anywhere. So the Terraform Cloud model can not only work in the cloud, but you can provision it on-prem if you so choose using our Terraform Enterprise form factor. So some of the features, we've discussed a little bit of this already. Using that infrastructure as code model, you can write and author and provision and share the resources that you already are accustomed to. The VCS connection is something we'll be focusing very heavily on today that allows that infrastructure as code to be managed just like any other code object within a repository and leveraging the existing flows that you and your developers might have around pull requests and merging and committing in different branches and all those sort of things. And we'll review that in the demo. We also have the remote operations phase, so that ability to do the dry run before invoking the plan and having the ability to have approval stages between them, as well as a fully formed API that allows you to interact with these things remotely or programmatically. Remote state management, collaborative plans and applies, all of this stuff, super exciting and very interesting to use in Terraform Cloud. We'll give you a link at the end to sign up, and there will also be a link in the post webinar email that you'll get if you want to sign up and give Terraform Cloud a try for free at any time. Using the VCS flow of Terraform Cloud, and this is sort of the segue into actually getting into the product, is very similar to the way that you use Terraform Cloud via the standard UI and also via the standard open source CLI, except that we intercept your infrastructure as code here at the repository level, and we interact with it directly upon action within your repository. So when you make a commit or when you do a merge, or if you do a pull request, actions can automatically be taken in Terraform Cloud to ensure that your infrastructure never deviates from the code that you've authored. Because we are a declared state model, we want to make sure that stuff is in sync. So we have the ability to have not only the private module registry, which we mentioned before, a private place to store your modules, as well as your workspaces. We'll review workspaces in a moment, and your Sentinel policies, which are policy management and governance as code. All of those things can be stored in that VCS repository as part of this strategy. So with that, who's ready for the good stuff? We'll flip into the demo. As we mentioned earlier, we're going to demo this today using GitHub. GitHub's pretty much the most popular option out there for VCS, but we do have options for the other major repo types, and I'll review those at the end. So with that, here we have Terraform Cloud. So Terraform Cloud, this is the UI for it. This is what you'd see if you first logged in to a brand new organization. This is my demo organization. I have a whole bunch of other ones. So you see this is what a fairly mature one looks like with lots of stuff already set up and active. But if we go back into our demo one, nothing is configured. Now, if we want to set up a repository to be acted on within Terraform Cloud, say my Clarity GitHub app that I've got here, this repository needs to be connected to Terraform Cloud somehow. So the way we'll do that is just by creating a new workspace. Now, workspaces in Terraform Cloud are sort of a logical unit that we use for managing pieces of infrastructure. Typically, a workspace represents a single repository. There are lots of different ways that you can use repositories, so it's sort of up to your own needs and use cases. But we'll create a one-to-one mapping right now by clicking New Workspace. And you can see right off the bat, we're presented with the option to connect to a VCS provider. Now, I've got a module repository here, but that's not what I want to use for a workspace. We'll say connect to a different VCS. And here I have all the different options that we support, all of their different flavors. There are many of them. But in this case, we're going to use github.com because that's where my repository is hosted. I click github.com and I'm asked to authorize that link into my GitHub account. So if we look at GitHub very quickly, we'll see I currently don't have anything installed here. There's no GitHub apps installed. But if I go ahead and authorize this, say authorize cloud, that'll pop us back over here, and you can see it's now listing all the repositories I have access to. Now, I have access to a bunch of HashiCorp ones. Those are not the ones I want to use. I'd like to use my personal GitHub repos. So we'll say add another organization. And here I'm prompted with a list of all of the different repository organizations that I'm a member of. You can see I'm at the top here. So we'll approve that. And we'll say we only want to grant it access to certain repositories, just for the purposes of this demo. So we can see here I've got my Clarity GitHub app. It's the one on top. We'll select that. And we say install. And there we go. The Clarity GitHub app repo is now available for me to use, and we'll select it. We'll use that repo name automatically as the workspace name, and we'll click Create Workspace. So that's been created successfully. Now, because every workspace is a distinct chunk of infrastructure, it's sort of similar to running, Terraform plan or Terraform apply from the command line on your laptop, or on your workstation within the context of a directory where you'd have things like TFRs, where you'd have things like environment variables that are preset that really, dictate the way that this functions. In this case, you can see none of that stuff is set up. That exists within Terraform Cloud, but that's still something that we need in order for it to function properly. So I'm going to pre-populate that just with a small Terraform script that I've written that manages variables within Terraform Cloud. This is a provider that HashiCorp publishes that's meant for use with the Terraform Enterprise and Cloud products. And you can see what it's just done is set up all of my different variables. And if we refresh this, there we go. So all the variables that I need for my applications, for my repository to function properly are now set up. And in fact, I also configured a notification that we'll go into in a moment as well, which is going to send some basic Slack notifications when things happen. Now, once this is set up, we need to queue our first run manually because we have to tell it what the existing state of things is before we can start detecting changes based on changes in the repository. So we'll say queue plan. And what that's going to do is actually ingress all of the config from my GitHub repository. It's going to run a plan. It'll run some other checks, and then it'll give us the option to apply that, which we'll do just so that we get a baseline to work from. So while this is running, it should just take another second. We have the full plan output here. Everything that's going to be created and done will stream here just like you're used to in the open source CLI. We have the ability to follow and export the logs, etc. The next thing that will run is a cost estimation phase, which will tell us how much this is expected to cost if it were to be applied, and the resources actually created. The cost estimation phase will tell us what it will cost. And in this case, we cost about $26.35 per month. And we passed a policy check. We'll review the policies in a moment. And in this case, I now have the option to confirm and apply and actually execute this run. So we'll do that, and we'll give it a chance to get started. And that's going to go actually build this application in AWS in this case. So the apply will stream here. Now, while that's running, if we flip back to the GitHub app screen, you can see I now have one installed GitHub app. It's my Terraform Cloud app. And from within here, I can configure which repositories it has access to. I can also uninstall or revoke its permissions at any time if I wanted to. So I can give it access to additional repositories that I have within my account, or I can just say, go for broke, give it access to all of my repositories. So give this just a second to finish creating. And while that's running, actually, let's take a moment to talk about what these policies are. So in this case, I've created a policy that enforces certain mandatory tags within an EC2 instance. Anytime I create an EC2 instance, it has to have specific tags applied to it, or else it will not be allowed to provision. So in that case, if we look at my my policies, we can see here at the bottom, these are the 3 tags I've said that must be applied to these resources: the app name, the app owner, and the cost center, just as an example of things that you might want to enforce during provisioning. These tags are being enforced currently, so my config was obviously in compliance when we provisioned it, or else it would not be running here. And we're all set. So that first run is completed. This was manually queued. So my apply is finished. Here's the apply output. I've got my address of my app here, which may or may not resolve yet. Sometimes DNS takes a few seconds. Yeah, we'll come back to that. But if we were to look at the instances, you can see that that app is now provisioned. It's running right here. And I have all of those tags applied here. So if we flip to the code for this exact config, this is what's in my repository. You can see, whoops, too far. I've got some tags applied here. Now let's say this is running, everything's fine, but now I want to make some changes. And as a developer or as a practitioner interacting with this, I want to commit some new infrastructure. And in this case, we'll just do some tag modifications because they're very quick. So we'll make a new branch. We'll branch this and we'll call it JS Webinar Demo. Why not? So now we've got a new branch of this code. And what I'm going to do is I'm going to delete this app owner tag. I don't want that anymore. We'll save it. And then we will commit that. And we'll push the branch up to GitHub. Whoops, wrong button. This button. Now, if we give that just a moment and I come back to GitHub and we look at that repository, we'll see we have that branch push pending for us. We have the ability to do a compare and open a pull request, and that's what we'll do. So we'll say compare and pull request, remove some tags was my commit message. You can see here, that was the change we made. We removed that tag. Let's say create PR. Now, automatically, because the Terraform Cloud integration has been configured, you can see we've got some checks that are pre-existing here in the pull request. In this case, it's going to do a Terraform plan, and it's also going to check those Sentinel policies to make sure that what we've done here is within compliance. So if we give that a few seconds, it should update, and we should have some more details. It's running in the background. It's connected to Terraform Cloud, and it's running what we call a speculative plan. So that speculative plan, and we can see what that looks like here in a new tab, this Terraform Cloud speculative run. This is actually, it's running a full plan, but since it was started from a pull request, it can't be merged. You cannot do anything with this. And that's sort of a safety measure to stop anybody from, changing infrastructure with what could eventually be unapproved code changes. So you can see in this case, the plan finished, but that policy check failed. And we reported that policy check failure here within the PR. So we can see directly within the details of that run, what changed, and what's missing here is missing required tag app owner. That app owner tag that we removed, that actually caused this merge to fail. So we'll come back over here and we'll put that tag back, and we'll actually add another tag. We'll call it webinar demo. Hey everyone. And we'll save that and we'll merge this again to the same branch. Okay. And if we come back into this PR, it should automatically update with the new merge, and the checks will run again. We'll run a new speculative plan, which again will just be a non-executable plan that will give us the details. And while that's running, maybe this has come up. There we go. There's our fancy demo app that we just provisioned within AWS. And once this finishes, should take just a few seconds, and all of the checks are passed. The plan and the policy check are both passed, we can merge the request, and we will see it come over back into Terraform Cloud for actual execution. There we go. So in this case, all of our checks were successful. No, it will be in a moment. There we go. All checks are successful. So this time the policy checks were successful. They passed because all of the mandatory tags were there. And in this case, we're going to make one minor change. We'll open this plan again. And that minor change is just the addition of this tag. And that's all. So we'll say merge PR, and we'll give that guy a merge. There we go. Merged and closed. We'll delete the branch. We don't need that anymore. And if we come into our main workspace, we can see we're now already in the planning phase. This is a real plan, not a speculative plan. That's actually executing this with the intention to run it once it finishes. And we can see all of the details from our PR are present here. So it's picked up, the source of it, which repository it came from, the username of the person who committed it. It's even got my avatar. You can see they're different in GitHub versus Terraform Cloud because it's pulling my GitHub avatar in. All of my commit information is in here. All the commit messages are present. The plan will finish. The cost estimation and policy check will run. In this case, the cost estimation should come back basically with a 0 delta because we're not changing anything. Tags are free. Policy check is passed. And now we'll confirm and apply it. Looks good to me. And once that confirm and apply runs, the apply should be fairly quick because we're just changing a tag. And by the way, Brutus says hello. I'm sure everybody can hear him. All right, so that modification is finished and everything is done. So if we come back over to our instances, the update is finished and that additional tag will now be here. There's our hi everyone, webinar demo tag. Now the tags are very obviously a simplistic use case, something that I just use as an example because it can get done super fast. But any infrastructure changes, any changes to your config can be managed and committed and worked with in exactly the same way. Now, during all of this, I mentioned at the beginning we had some Slack notifications set up. If I slip into Slack, we can actually see this notifications channel here. This is just receiving notifications from my Terraform Cloud instance. Every time that a run was created or that something required attention, Terraform Cloud is automatically notifying me via Slack that there's something that needs action. And in fact, via this module, this Slack notification module that's part of my Terraform config, I even give myself the IP address of the server that I created in case I need that, because it lives behind a load balancer and it may be difficult to find. Now this module is important because we're actually pulling that module in using that private module registry. So this is that way for you as a team or a corporation or even just yourself to have an isolated module registry that belongs just to you, that contains code that you've built and that you control, who has access to, who can see it, who can use it. So in this case, it's my Notify Slack module. And if we click on details, excuse me, click on details, we can see here it's actually coming out of one of my GitHub repositories as well. This is a module that just uses Amazon's SNS service to create a subscription and a Lambda function that fires that Slack notification off anytime I create an EC2 instance. The private module registry has all of this information about how to use the inputs and outputs and instantiate this module within your code. This is all part of the module, so it's super easy for you to publish this for other folks. And all of these versions here are actually coming from tags within my GitHub repository. So the VCS flow helps provide you, this connection as well. Whereas if we wanted to add a new module, I can look at any of these VCS module repositories and see anything that has the proper, module repository format will be available for me to import. I only happen to have the one right now. If you had tens or dozens or hundreds, they would all show up in here. You could add them just like you created that workspace initially. Similarly, our policy sets, which are how Sentinel policies, that kind of monitoring, or I'm sorry, governance as code is instantiated. Those are all done here via the same sort of flow, where you can pick a VCS provider, choose a repository that contains Sentinel policies or policy sets, and link them directly to your Terraform Cloud organization as well. So everything really revolves around that VCS flow. Once you've established that connection, things get a whole lot easier and a whole lot cooler within Terraform Cloud. So that sort of wraps up the demo portion. Now, as promised, I don't have time to do these for each of you, for each of these different flavors of VCS provider, but the same functionality is available for GitLab, where we have this integration with their merge requests and their pipelines. Bitbucket, same sort of deal. We have all of the same merge requests. Checks show up right within the flow. And even Azure DevOps, this Azure DevOps capability was added just recently in the middle of December. So we now have this capability to do checks and pull requests, all that sort of advanced, kind of developer VCS flow within Azure DevOps as well. So just to kind of summarize what it is that Terraform Cloud brings you, there are 3 tiers of Terraform Cloud. There is that free tier. You can sign up right now if you want, before the end of this discussion, at app.terraform.io, app.terraform.io. Limitations there are mostly that you only have, 5 users, and we don't have any kind of gold tier SLA driven support, but you can email us. We have the VCS integration is there, workspace management is there, variable storage runs and applies, all that great stuff is all there in the free tier. If you want to move up to the team tier, our pricing is very fixed and very transparent. The team tier, for $20 per user per month, adds a couple of things like team management, roles, access control, all that kind of stuff. And then the governance layer on top of that adds cost estimation, Sentinel, the policies as code that I showed early on in the discussion. Wrapping up, just a couple of links. Understand it's hard to get links from somebody else's slide deck on somebody else's screen, so we will be emailing these to everybody, but you can sign up for free for Terraform Cloud today. We have our Learn platform. HashiCorp Learn is a recently launched platform that allows you to take, CBT training on specific topics. We have a getting started module for Terraform Cloud that will help you get started with using it right away. We also have a VCS specific one that's all about how to connect your VCS and kind of do the stuff I just showed. And there's more info on the paid tiers out there as well. The email that we're going to be sending out also has some links to a couple of blogs, as well as information on where to find the documentation for setting up your specific flavor of VCS within Terraform Cloud. So I've seen the Q&A is pretty active, and I guess this is a time for Carolyn.
Yes. Okay, we can move over to Q&A.
All right.
Thank you for that presentation. That was great. So I do have some questions here, so I'll just go in order of when they were asked. And then if there's any questions that we're not able to answer, feel free to email them to me directly at cguo@hashicorp.com, and then we can get them routed to the right people as well if we're not able to answer them today. So first question, so this was during your demo, John. I think we had someone in the audience who said that we were moving through the demo a little bit quickly, so they just wanted a quick recap to level set and understand what was done and what the overall goals you were trying to do.
Yeah, sure. So, overall, the goal here was to highlight, what it is that Terraform Cloud provides as an extension of Terraform open source, and then how to link it to your version control repositories so that those can be sort of your central point of truth for managing infrastructure as code, and how to find, quick value in tying Terraform Cloud to those repositories.
Okay. Great. We have another question about whether the webinar is going to be recorded. I will answer that. It is
Yeah.
being recorded, so we will be publishing the recording on a resource page, and then we'll share it out to everyone who registered for the webinar, probably within a couple business days, so expect to hear from us early next week. Okay, next question. Can you share sample Terraform code that populates the Terraform variables and environment variables in the Terraform Cloud Workspace?
Well, I'll tell you what. I'll do this. If we look at, this is the CLI. Oops. I can't show you the sample code because it's full of like all of my secrets and stuff, and that would be terrible. But here's some example code that's within the Terraform TFE variable resource within the Terraform Enterprise provider. The sample code is right out there on our docs page. It's really it's real straightforward to use. The important thing to note is that there's two different types of variables. There's Terraform variables, which are those TF variables, and then there's environment variables, which are categorized as ENV. Those two different categories determine how those variables are uploaded into that Terraform Cloud resource. You don't have to do any real setup. You specify the workspace name, and then you just give it basically, this code right here is fully functional, for example.
Okay, great. And then this is a roadmap question, and this might end up getting directed to another team, John, but one of the attendees asked, is something planned to allow tags instead of PRs?
Yeah, it's probably better we don't discuss that in the webinar, but it's totally fine if you want to email Carolyn. We can discuss that via email.
Okay, great. And then, do you have the URL for the workspace environment?
I guess I should make a repo for that. It's very small, but yes, I'll create a repository with a sample code for that workspace environment variables, and I will give that to you, Carolyn, to send out after this. Okay,
great. Next question: how do you organize your branches when you have multiple environments?
Well, that's everybody's favorite question, favorite answer, I should say, is it depends. It really does totally depend on how you structure your teams, whether they combine their app code and their infrastructure code into one repo, whether you use sort of a mono repo format or whether you have multiple repos for different pieces of applications or infrastructure. It really does depend. It's very flexible. The tool is able to support lots of different ways of working. So for example, if we come back into the workspace here and we look at the VCS settings for this, you can see it's looking at just this base branch. I can tell it which branch I would like to use. I can also tell it if I want to use subdirectories underneath this branch so that we can have sort of a larger branch with individual folders underneath it. Or if we want to have one large repo and monitor specific branches for merges, it really does depend on how you want to work. In this case, I went very simply and monitored the master branch for merges. But of course, I was making my changes in a feature branch that I then merged into the trunk.
Okay. Also, another question, what type of parrot do you have?
The one who's talking here is a double yellow-headed Amazon. I have several plugged for animal rescue, but yeah, the one that you're talking to is a double yellow-headed.
Great. Okay, and then we have a few specific questions in regards to AWS. So someone asked, I have a repo that has modules for different services in an AWS account. Am I correct that I should have multiple workspaces connected to one repo, but using different working folders for the main.tf?
Yeah, again, similar to that previous question, it sort of depends on how you've structured your repositories. You could do it that way. You could also, I mean, You could choose to have multiple repositories, for one for each service in this case. But yes, you could have multiple repositories connected to the same repo with different base folders or different branches. Yes.
Okay, great. And then I have a couple questions.
I see that one. No, there's no dark theme. That would be super dope. But no, we don't have one.
Okay, I'm gonna try and bucket some of these questions so we can get to most of them. So we had some questions around ADO, GitHub, GitLab, Bitbucket. So for ADO, we have an on-site ADO instance. Will that work, or does it need to be internet facing? And then for GitHub, Bitbucket, GitLab, will the internal versions of that work with this, or will it have limited functionality?
So the answer is it depends. Absolutely, it's capable of working with it. We absolutely totally support connecting to on-prem instances, of course. However, it does need to be at least open to the IPs that Terraform Cloud is using to connect to your repository. So if that is not acceptable, and we totally understand why it might not be, Terraform Enterprise might be a better option, because that's an installable version of Terraform Cloud that lives within your own four walls, within your data center, and then of course can touch whatever resources you give it access to in a much more limited scope. It looks and works and feels and walks and talks exactly like Terraform Cloud, but it is something that you own and install and manage, as opposed to being a SaaS service. It has a little bit different pricing model, but that's all on the website as well.
Okay, thanks, John. And then we do have a couple questions about SAML SSO being available for the cloud offering. Not sure if John is the best person to answer this, but if you have any insight on that, feel free to add. Otherwise, we can send out a follow-up note.
Yeah, I think we should contact that individual directly.
Okay. Great. We do have a question from Scott around comparing and contrasting Terraform Enterprise and Terraform Cloud. So if you actually head to HashiCorp.com /products/Terraform/offerings, you'll be able to see the full set of feature comparisons across Terraform Cloud, Enterprise, and then the different tiers within Terraform Cloud. So that should give you all the information that's needed in terms of feature by feature comparison. The key difference also is Terraform Enterprise is a private install. Terraform Cloud, anyone can go sign up for free. And then John, if you have anything you want to add there, feel free. Otherwise,
nope. That's the best way to learn about it, because there are nuances mostly around limits to how many things can run concurrently, and how many users, and the limits are very nuanced. They're hard to kind of discuss in this sort of format, but it's all kind of spelled out on the website. And of course, SAML authentication is one of the highlights of Terraform Enterprise, because it coexists on your data center.
Okay, great. We also have a couple questions here around migrating from one VCS to another. Can you use more than one VCS simultaneously?
So yes, I mean, migrating from one to the other, it's not something that we manage for you, but if your repo moves someplace else, you would just connect that new repo to the workspace. So you can do that. As far as using multiple VCSs simultaneously, absolutely. So if we actually switch to my main workspace here, I have repositories set up within, actually, here's an easy way to see it. I have repositories in Bitbucket, GitHub, GitLab, no Azure DevOps in this one, it's separated, but yeah, absolutely. It's all, you can have as many as you want concurrently.
Okay, great. Let's try to get to a few more of these so we can wrap up by the 9:45 a.m. PST. So, okay, we have a question around, is there best practices for managing the CI pipeline when using multiple cloud providers?
Um, I'm going to say there's not really a HashiCorp published best practice because it's another one of those. It depends. It depends on what your CI provider is, what your pipeline tool looks like, what your providers are. It really we see Terraform as a multi-cloud tool. So your Terraform configs could absolutely contain resources in multiple clouds. There's no reason that they couldn't or shouldn't. But as far as what your CI pipeline does with that, tests, for example, against an AWS outcome may be different than the tests for an Azure outcome. So it may logically make sense to separate those tests and maybe have multiple stages in CI, which might require you to have multiple workspaces in order to bucketize those executions so the tests are simpler and easier to run. If that's not a concern that you have, then you can put them together. It does depend on what you're trying to do as far as generating outcomes and what the goal is.
Okay, and then let's try to get through a couple more. Someone asked, do I need to write different commands to spawn up a machine on Azure, AWS, GCP, or would it be a single piece of snippet that that can be sent to machines with different cloud providers?
Yeah, so the provider code is different for each. So again, it's similar to this enterprise provider. If you use the Azure provider or the AWS provider, the code will look different because the resource types are different. So if we look at the code I used here for AWS, you see, for example, I'm very specifically creating AWS subnets and routes and forward-facing gateways, VPCs, whereas in Azure, you'd be creating Azure Resource Manager VNets, or ARMs instead of EC2 instances or VM instances. I forget what they call security groups. Maybe they're just security groups. But regardless, the provider is different, and you instantiate that provider here within the code. In this case, I just called the AWS provider. You can call as many providers as you want. So if you wanted to deploy this on Azure, it would be the same general format, the same relationships and the same interpolative syntax within HCL, but the resource names will be different because it has to interact with that Azure API instead of the AWS API. You can mix and match them within one config, but you would have to call that other provider instead.
Okay. We also have a question that's specific to AWS. John, do you know what the IAM setup for Terraform Cloud is to work with AWS?
I saw that one. The answer is fairly generic. We can do whatever you tell us we can do. So Terraform does not require any specific, God level or root access to your AWS account. If you don't give it access to create or manage a resource type that you request, it won't be able to do it, and that'll fail. But if you are in a situation where hey, these are the 4 resource types I need to be able to provision and manage, and I can give them read-write access, no delete, just create and update perhaps, and grant that role to the IAM key pair that Terraform uses, then you can do that. So the concept of least privilege is possible because we don't require any kind of specific root access to log in there.
Okay, thank you for that response. Okay, and then I know I said let's do 2 more a few back, but this time for real, let's do 2 more.
For real. I'm counting down.
So what's the best way to handle stages, dev to QA to prod with Terraform and VCS? And then in parentheses, same modules, but different variables.
That's another it depends answer because it can be very flexible. It depends how you've broken down those environments. I tend to call them environment stages, whatever. If they have their own repositories, for example, then that becomes a kind of an easy answer. They link to different workspaces. If they would execute within the same workspace, there is some forthcoming capability to be able to chain workspaces together that may be able to help you there. Otherwise, it is going to be probably dependent on variable management and doing things within your whatever it is you're using to call Terraform, your pipeline, for example, to instantiate and change those variables, as you move along between those different stages and say, hey, it's the same code in the same repo, but in dev, I want, a cluster size of 2 because it doesn't need to be huge, but in prod, I need a cluster size of 20 because it's going to handle production workloads. Changing that variable is something you can do with that Terraform Enterprise provider. So you parameterize it out, change it dynamically, and make that part of your CI flow, CD flow, I guess.
Okay, great. Okay, this is our last question. So if there's anything that we weren't able to get to in our session, again, feel free to send me an email and I can get you routed to the appropriate team or get you routed to the appropriate response. My email is cguo@hashicorp.com. So the last question is, where are the Terraform state files stored? Can we access it in case we want to?
Aha. All right. I keep going back to that thank you, and then we keep having to come back over here. The answer is the state files in this case in Terraform Cloud are stored in the remote backend. So that's part and parcel with me configuring that remote state in my Terraform config where it communicates with the workspace. The state file is a component of the workspace in that case. So this app that we provisioned here, you can actually see we have a states tab. If you click on that, you can see every version of the state over time as it has changed. So it's a change tracked state management. And in this case, after that PR was merged, here is the actual state as it sat when it was created. And yes, you can download that as a raw file that you can use later, or you can see just, here in the UI, there's a diff view and all that kind of useful stuff.
Great. All right. Thank you, John, and thank you to the audience for those questions. Glad to see everyone was very engaged. So to wrap things up, I hope everyone enjoyed today's webinar and have a better understanding of VCS and Terraform workflows. Again, if you don't have Terraform Cloud currently and are interested in trying it out, you can sign up for a free account at app.terraform.io. It will be free for up to 5 users. And then if you're interested in Terraform Teams or Governance, you can upgrade your account in the billing section of the app. And finally, as mentioned at the beginning, the webinar has been recorded and we'll make the recording available within a few business days. I will be sending out an email to everyone who registered with the recording link. All right, have a great day, everyone, and thank you.